Okay. Okay, so attendance is open if y'all want to go ahead and click in on attendance. Good morning. Y'all ready for the end? No? I like want to get it over with. That's we're this close. It feels like this semester took forever, and then at the end, it went really quick. I don't know about y'all. Let's see, I need my chat. So make sure you go ahead and do attendance. Well, it's not done yet. It's in progress. So it's, I'm just gonna make sure it's right, you know.
The review thing that you put up, is it the same one that you gave the tutoring center?
Exactly the same one. So I'm gonna let the tutoring center know at the end of class today how far we got, so that they're not repeating what we're doing in class. You know, for those who don't come to this, like my sections, they can go back and do theirs that we covered in class, but y'all, you know, I'll just tell them where we left off. Yeah. So how many people going to the tutoring tonight? It's tonight in Shaver Gym. Now you registered, right? Okay, to make sure that you have a spot for yourself, you have to go and register. If you want to go, I think there are still spots available. So on the Moodle site, I can pull it up. On the Moodle site, I posted here, final exam practice questions, and this is the link to sign up. So if you're missing that email that I sent earlier, it's here on Moodle. Okay. Oh. So if you are in 4T, your exam will be on Thursday, the 19th from 1 to 3 p.m. Jacob, if you're having trouble with the Reef app, completely shut down your device and then start it up again. Usually if it's a phone, that fixes it. So completely shut it down and start it again. Yeah. And if you're in, you should not be watching if you are in the 5T section, but the 5T section is on Monday. But the section we are in right now, you will have your exam on Thursday. Okay? So we got a minute before class starts. So y'all want to hear some gossip? So did y'all hear that oxygen and potassium went out on a date? Do y'all want to know how it went? It went okay. To knock out, yeah, yeah. You could do some more plays on words there. Yeah. But you know, I don't know if y'all been watching the news. You know, they published a new study out that there's a genetic link to for people who have diarrhea. Did y'all hear it runs in your genes? It was funny. I enjoyed it. Okay, make sure you checked in on attendance. It's only 46 today. That's not too many. Okay, so today is the last day for jokes and for clicker. So I'm going to update clicker grades over the weekend. So whatever you see on your device at the end of today, that's what I'm putting into Moodle. So sometime over the weekend, it will be updated, okay? A 70% in order to get the A, and then it's a 10-point scale after that. The other thing I wanted to tell y'all know when y'all log into Moodle and you see a request for a course evaluation? Some of y'all have done it. Yay, thank you. I am going to make you an offer. I will give you 5 bonus points on your exam if 80% of our class responds to the course evaluation.
When they put your evaluations, like mine never pops up on my board, and it's not an email. And I emailed my advisor, she was like, it's not mandatory, don't worry about it.
I don't know the answer to that. I don't, it should pop up for everyone. So right now I checked in 4T, we have 53% who have completed the evaluation. So we need to bump up. If we can get up to 80%, everybody gets a 5-point bonus on their final exam. Okay. So make sure you go and do that. It does close tomorrow. And close is, I don't know what time tomorrow. So try to do it today. There you go. Start with chemistry. There you go. Start with the best, right? Start with chemistry. All right. Exam review, right? Y'all know I sent you an email and I posted the final exam practice questions right here. So I posted 2 things for you. I posted a blank one. Why it does that? A blank one, and I posted the answers, right? So that I know we're not going to get to every single one. It's big. It's bigger than the exam's going to be. But it gives you some practice, okay? I think that's what y'all need the most is practice. Not studying and reading. Yes, you should do that, but I think you really need practice, application. So whatever we don't get to today in class, hopefully the tutoring center will pick up at the tutoring thing tonight at 5:30 in Shaver Gym. And then anything else, you have the answers, okay? And you can email me any questions you have. Okay, let's see. Oh, and here are my suggestions for if you want to know how well you need to do on the exam. There's a final exam, final grade calculator. So you follow this link and you must download the Excel spreadsheet. You cannot edit it until you download it. And you would type in the scores. Oh, try logging into Moodle on Google Chrome. Do you try Chrome? Okay. No.
She's just gonna email me the link and then I'll just click on it.
And then you click on it. Okay, that'll work. All right, so for your exam calculator, what you want to do, if I could scroll over here, it won't let me because I'm not editing it. But in the percentage column, you pull your percentages and you put them in here. And this is the one that's going to vary because you don't know what that is yet. So you anticipate, maybe you think you're going to make an 80, maybe you think you're going to make a 72, whatever you think you're going to make, you put it here and it will give you your final score for the class. Okay. A lot of people asked, and so I just went ahead and made an Excel spreadsheet so everybody could do it. Okay. Good on that? All right. Oh, and I didn't mean to close Moodle all the way. But is there going to be free response? A small portion. Majority is going to be multiple choice. Majority multiple choice. Okay, my reminders to you are to bring a calculator for the exam. You need to bring your own calculator. I will have no extra calculators, and it's not like it's on Respondus where the calculator's there. You need to bring your own approved calculator. You also need to bring writing utensils. Everything else I will provide. I will provide your exam, I will provide your answer sheet and scratch paper, and I will provide the exam resources. Make sense? All right, now, do not arrive late. When the first person leaves, nobody else comes in, okay? So do not come late, come on time. Okay, your lowest test score has already been dropped, Holly. It's already been dropped on Moodle. Okay. All right, so what do we got now? 63, if you haven't done attendance, last chance. All right, so I can close this. So let's go do a few clicker questions, and then we're gonna go on to our exam review. I thought this was really cool. Maybe it'll go, look, and now it won't go. Oh, there it goes. Isn't that kind of cool? All right, so these are our very last clicker questions. All right, y'all ready? Calculators out? Y'all aren't ready. Calculators out. All right, now we ready? Okay, let's do this. So 63 is what we have. All right. Move this over, like all this stuff. Here we go. Okay, the name given to an aqueous solution of HBr is blank. A minute and a half. Ten seconds. Okay. So what did y'all say? Hydrobromic acid is correct. Hydrobromic acid. Okay, so if we have HBr, what happens when we put it in water? What's going to happen? It's going to do what with this hydrogen? That hydrogen is going to get donated to the water. So it must be in acid, right? That's the definition of an acid, that we do what? Donate our proton. So then we would make Br minus plus H3O plus, right? So we have to be an acid. So when we look at this, this is a binary acid. If it's binary, how do we name a binary? We always write hydro, and then we put the element, and then we put IC acid. Hydrobromic acid. Okay? All right, did I mark it as correct? Yes, okay. And Jessica, if you, even though you still see your grade, it has been dropped. If you take the 4 grades and you average it, you'll get a number, and then pull out the lowest one, average those 3 scores, and you'll see your score on Moodle is the average of the top 3, not of the total 4. All right, so next one, let's see, where, oh, I moved the little thing. Where'd it go? Where are my PowerPoint controls? Let's see. Do this. Oh, come on, stop it. Oh, that's not what I wanted. There we go. Okay, try this again. Too many things on the screen. Okay, what is the pH of a solution that has a concentration of H3O plus that equals 8 times 10 to the negative 4 molar? So you do need a calculator for this. Remember, a minute and a half. Ten seconds. Come on, y'all, click in. Okay. So whenever we're calculating pH, what's our formula? pH is equal to the negative log concentration of H3O plus. Do you have to know how to put this into your calculator? Yes, 8.0 times 10 to the minus 4. So what should you have gotten? Oop, that's not what I wanted to do. My bad. Hold on, there we go. So you should have gotten B. You should have gotten B, okay? So when you put that into your calculator, you have to be able to do that. I'm telling you that you'll see problems like that on the exam. You have to be able to do that, okay? I know I'm gonna clear that one that I just opened and closed. I'm gonna clear it. I know, nobody's clicked in on it. I'll clear it. pH isn't negative. pH is 0 to 14. I mean, theoretically, yes. Technically, you can get a negative pH, and you can technically get a pH above 14, but you're never going to see it. Okay, so I will provide the same exam resources as what you've gotten on your last exam. Jordan, it's just because I opened and closed another question, and I'm going to go ahead and clear that, so don't freak out. Okay, here's a really, really, really difficult one. Really difficult one. This is your last set of clicker questions, right? You deserve one easy question. Here's your easy question. What is 1 plus 1? I think y'all can handle this one. You need some more like this? Is that? You think it's D? I hope not. I figured y'all could use a good laugh. All right, let's see. We need 63. I think we had 63. I'm really going to close it in a minute and a half. That's going to be sad when someone chooses D. I'm going to cry a little bit. I thought we had 63 people instead of 62. I don't want to close it on somebody. Come on. We're all going with B. Yes, I think we're all on board with going with B, right? It's E, that's what it is. It's E. 10 seconds, less than 10 seconds. I'm closing it. It's my freebie for the semester. Okay. So what did we say? Wait, that's when I graded. There we go. Woohoo! Oh, thank goodness. Okay. All right. You wanted to use a calculator? All right, here we go. Now you got to think about this one a little bit. An acid and a base react to form a salt and water in what kind of a reaction? Y'all are sweet for putting up with my sense of humor. Guess we had 62 last time, but I said a minute and a half in case somebody gets back on. I'll still give a minute and a half. 10 seconds. Okay, so what did we say? It is a neutralization reaction. It is a neutralization reaction. That is correct. Remember, you're going to make salt and water. Those are the two things you're going to make unless you have something with carbon in it. And then what else are you going to make? Carbon dioxide. Then you would also make carbon dioxide. You would release it as a gas. Okay. Well, second to last one. What type of solution is one with a pH of 8? A pH of 8. Ten seconds. Look, now we're 63. I don't know how that happens. Okay. So tell me, what is the pH of a solution that is acidic? So this is something that is less than 7. Basic. Greater than 7. Neutral. Equal to 7. Physiological? Is it 7? Not quite, it's not 7. It's actually a basic solution. It's about 7.4 to 7.6, somewhere in there, right? That's our range of physiological. So which one is this? Let's see what y'all said. It is basic. It is basic. Okay. All right, last one. You ready for the very last question? Clicker question of the entire semester. Duality of All right. The best joke teller on campus. Who is the best joke teller on campus? Is it me? Is it Dr. Clune? Is it Boots Clune? He's so cute. Or is it the Colonel? You tell me. Boots is cute. Boots is so cute. He definitely has me beat on cuteness. I don't know about jokes though. Yes, it is. It is a periodic table scarf. It is one of my prized clothing pieces. I love it. It's a tough choice. I know it's a tough choice. All right, so we have 63. All right, so let's see. What did y'all say? Yay. Y'all better vote for Dr. B to get extra credit. You have to evaluate me to get extra credit. It does not matter what you write as long as you tell the truth, but please do the evaluation, right? Okay, all right, so I hope that was kind of fun. Let's see if I can get out of this now. All right, there we go. Okay, don't say it. Now, y'all ready to do some chemistry? Yeah? Okay, so it's like I made like 3 exams in the last about week for y'all. This one, the regular exam, your last exam, so I've been in the exam making mood. Now, the questions on here cover the content that we've covered in class, but do I have one question for every single possible question that could be on the exam? No, no, but it's a good smattering. It's a very good smattering. So I want you to try whatever we don't get to in class, try at home, try with the tutoring center, because don't put the key next to you. Do it on your own, just having those exam resources next to you so that you can try and start evaluating, oh, I'm good at this, oh, I didn't get that, right? So you know what to go back and kind of study, okay? Did them 2 weeks ago, good. Yes, I'm glad y'all did them. All right, so blast from the past, significant figures, scientific notation, right? Okay, so we have our measurement. What is it expressed correctly using scientific notation? So all you have to do is move the decimal place so you get a number between 1 and 10. It'll be both math and vocabulary, Jennifer, just like the exams. It'll be both, okay? 1, 2, 3, 4, 5, 6. So 4.3 times 10 to the, and what direction did we go? So that makes it -6 because it's less than 1. Okay, not too bad, right? All right, which of the following numbers contains the designated correct number of significant figures? So you tell me in A, how many significant figures? So remember, is the decimal present or absent? The decimal is present, so the Pacific Ocean is on that side of the US. Do you remember my US little thing, right? So if this, there's Florida, it's a terrible US, right? Pacific and Atlantic Ocean, and everybody wants to come into the US, remember that? So how many significant figures? You get to your first non-zero number and you start counting. So how many significant figures? These are 4. 4 does not equal to 5, so A is wrong. Okay. B, how many significant figures? 3, so that's wrong. C, how many significant figures? 3, because it's absent, so we're going to come in this way, and these 3 are significant. So this one is correct. This one we came in here, and those 3. Okay, so this one is correct. How many in D? This is 3. They're all significant. How many in E? 5, because we're coming in here, the decimal's present, so So it's 1, 2, 3, 4, 5. So it's 5. Okay. So I'm trying to remind you not to forget the things that that we did a long time ago. Okay. Which of the answers to the following conversions contains the correct number of significant figures? When I'm doing this, what do I base my numbers of significant figures in my answer on? The lowest number of significant figures, but a lot of times what I give you is I give you a question. I say, you know, you have 2 liters of sulfuric acid and you add it to, right? You know, I give you all this information. And so when you're looking at the text of a problem, the number of significant figures are based on the values in the problem. When you go and do your calculations and you use conversion factors, do you base the number of significant figures on your conversion factors or what was given in the problem? What was given in the problem. Conversion factors have unlimited amount of significant figures. So we don't base it on that. So you have to look at the values that were given, and this is what we base our answer on. Does that make sense? Okay, so in A, how many significant figures are we given in the problem? We have 4 significant figures. How many were given in the answer? 7 significant figures, so that's not right. In B, how many? 1. In the answer, 3. C, answer, 4. Ah. In D, 3. And answer, 2. 2, because the decimal's absent, so we cross those out, so we have 2 significant figures. In E, 3. In the answer, 2. So the only one that matched was C. Okay. All right. Which of the following measurements are not equivalent? How do you do this? You have to do a bunch of little conversions. So if I have 25 milligrams and I want to go to grams, where are milligrams going to go? On the bottom. So milligrams on the bottom, what's going to be on the top? Grams. Now, you're going to have your equation sheets, right? All that exam resource stuff. But on your resource sheet, it puts that as one thing equals another, right? So you have to figure out what's going to go on top and what's going to go on bottom. So how many milligrams in a gram? 1,000 milligrams in 1 gram. A milligram is tiny, right? Usually that's how much medicine you have in something you take. It's so many milligrams per tablet, right? Okay. So 25 divided by 1,000 gives us what? 0.025 grams. Oh, let's do the other ones just because you need to practice. Okay, 183 liters. What goes on the bottom? Liters is going to go on the bottom. Okay. What's going to go on the top? Kiloliters. What's in how many kiloliters, how many liters in a kiloliter, or how many kiloliters in a liter? Can you go look? What does kilo mean? Kilo means 1,000. So if I have a kilogram, is that bigger or smaller than a gram? It's bigger. It's a lot bigger, right? So a kilogram must be a lot bigger than a gram. I'm sorry, a kiloliter must be a lot bigger than a liter. So you have 1,000 liters in 1 kiloliter. So what do you have? .183 kiloliters. All right, let's do the next one. I have 150 milliseconds, and I want to go to seconds. So what goes on the bottom? Milliseconds. Okay, what goes on the top? Seconds, that's what we want. So we're going to cross out milliseconds. How many how many of which one? There are 1,000 milliseconds in 1 second. So what do we get? Okay. All right, D, 84 centimeters. And I want to go to millimeters. Could you do the conversion from centimeters to millimeters straight out? Sure. But what if you've kind of forgotten? Let's go to meters. Let's go to meters, because that's probably what most of y'all would do. So there are centimeters on the bottom, meters on the top. So how many centimeters in a meter? 100 centimeters in 1 meter. Now we need to go to millimeters. So I put meters on the bottom, millimeter on top. Milli is 1,000, so there are 1,000 millimeters in 1 meter. Well, what actually happens is that these zeros cancel out. So you could know that there are 10 millimeters in a centimeter, but you don't have to know that. So what do you get? 840 millimeters, right? So this one's not right. Okay, let's do the last one. We'll do it up here. 24 deciliters. Okay, we want to go to liters. Do we know how many deciliters in a liter? There are 10 deciliters in 1 liter. So you should get 2.4 liters. Yeah? Those conversion factors, you got to get comfortable with them. All right? So which of the following setups would convert centimeters to feet? Centimeters to feet. Take a look. I'll give you a minute. You might have to draw on a free response. Might. Okay, so what do we think? If I want to go from centimeters to feet, what am I going to do? If I can go from centimeters to inches, then I can go from inches to feet, right? 2.54 centimeters in 1 inch. And how many inches in a foot? 12. Okay, and it didn't actually ask you to do the math. It just asked you to set it up. So that is C. Right? So sometimes you're going to see questions like that where I just say, what's the correct setup? Right? I do want to know that you can do it in your calculator, but I also want to know that you can know the correct setup. All right, I know this was kind of the bane of your existence for a little while. A doctor orders 125 grams of ampicillin. The liquid suspension on hand contains 250 milligrams per 5 ml. How many milliliters of the suspension are required? What are we going to start with? You could. I'll suggest to y'all that it'll make more sense to you if you start with a value that doesn't have a denominator. It just like makes the math easier because you have 1 unit here and you're looking for 1 unit. So it'll make more sense to y'all if you start with the one that has the same number of units. So if we start with that, that's 125 grams of ampicillin, right? Now, we're trying to get to milliliters, so what do we need to do? We have to start with grams on the bottom. But we're trying to get to milliliters, that's okay. Do I have a conversion factor that has grams? No, I have one that has milligrams, right? So what do I need to do before I can use this conversion factor? I need to convert to milligrams. So do you know how many milligrams are in a gram? 1,000 milligrams in 1 gram. Now that I'm in milligrams, I can use that. And I know up here it says I have 250 milligrams per 5 milliliters. So what cancels? My milligrams cancel, my grams cancel, and I'm left with milliliters. So what do you get? I love those calculator sounds. Loving them. 2.5 milliliters. Yep, C, that is correct. Good. Sorry, y'all. All right, so this is way back when density. Anybody remember the formula of density? Density is equal to mass over volume. Okay, so we have a gold nugget with a mass of 521 grams. It's added to 50 milliliters of water. The water level rises to a volume of 77 milliliters. What does that tell me about my volume of gold? It's the difference between the two, right? So our volume of gold is equal to 77 minus 50. What's 77 minus 50? What? 13 milliliters. Okay. What are my units on density? Am I in the right unit? If we say mass per volume, but that could be any unit, right? What unit do I want to make sure that I'm in? Look at all the answer choices. They're all what? Grams per mil. Okay, so we are in grams per mil, but I wanted y'all to kind of think about that. So what do you get? 521 divided by 13. 20, that's not 20, 13, 27. Thank y'all. What do you get? 19.3 grams per mil. Okay. All right. Which of the following substances will float in gasoline, which has a density of 0.66 grams per mil? What's going to float? Things that have a higher density or a lower density? Things that have a lower density. If it floats, it has a lower density. Like, remember we talked about water being this super special substance where it is one of the only substances on the planet that its solid form is less dense than its liquid form, and that's why ice floats in water, right? So remember, whatever floats has a lower density. So we're looking for a density that is lower than 0.66, so which one is the only one? B, balsa wood. Okay. All right. Now, you need to match the type of measurement to the unit given. So what's an example of mass? Mass is what? Is grams. So grams is mass. What else? The base unit, absolutely. But where else do I see grams? Milligram. Okay. All right, volume. So we did mass. Volume. Milliliter. Anything else? Just milliliter, that's the only one. How about distance? Millimeter and kilometer, kilometer. Yeah. Temperature is Kelvin, right? So there's Kelvin, there's Fahrenheit, there's Celsius, those are all temperature. Density we said is a combination, right? In grams per mil, but some kind of mass per volume, right? So it's a combination of two units. Select the correct prefix to complete the equality. What should you have up right now? That table from the back? The table in the back of the book that's on your exam resources that have all the conversions, right? Okay, in 1 gram, there are how many kilograms? There's 1,000 kilograms, so that would be A. What? Okay, in 1 meter, no, that's not right. That's not right. There are 1,000 grams in 1 kilogram. So how many kilograms in 1 gram? 0 point, how many? 0.001, right? It's 3. So it's basically saying 1 divided by 1,000, right? Because there are 1,000 grams in 1 kilogram. So if you do 1 divided by 1,000, you get 0.001. Okay, how many millimeters in 1 meter? Oh, so wait, that was G. Okay, now what? How many millimeters? 1,000, so this one's A. Okay, how many millimeters in a centimeter? We just did this one. 10, right? Okay, how many milliliters in a deciliter? How do you do that? So say you have 1 deciliter. How do we get to milliliters? There are 10 deciliters in 1 liter. There are, in 1 liter, 1,000 milliliters. So how many? Right, just cancel one of your zeros. 100. So 100 is F. Yeah? Okay. How many grams in a kilogram? A 1,000. Okay. And how many cc's in a mil? This is one that is a unit of volume, but usually where do we see cc's? In a syringe, right? So how many cc's in a mil? 1. 1. That's the definition of a milliliter. 1 cubic centimeter, 1 cc. Okay, so that's C. Okay. All right. When a solid is converted directly to a gas, the change of state is called what? Sublimation. It's called E. What is freezing? We go from a liquid to a solid. What is melting? What is boiling? What is condensation? So when you do this, when you study with this, this is one way to help you to study. It's to not only select the correct answer, but then to go in and look at the other answer choices, because that's going to help you study more effectively, right? Have you ever done that before? Kind of try to do that. Okay. In a gas, the distance between the particles is what? Very large. It's very large relative to the size of the molecules, right? And that's exactly what we see when we take water, right? And we go from freezing to melting and then to boiling. And once we go to a gas, right, they're all over the place, very, very far. All right, helium is what kind of substance? Helium is an element, right? It is an element. It's not a mixture, right? A mixture has to be more than one thing. Heterogeneous mixture tells me what? You can see the difference, right? You can pick out the difference, like sand and water, right? They're not gonna, you're gonna mix them together and you swirl them up, right? And it'll be all distributed, and then you let them settle, and the sand will settle to the bottom, right? It'll still be a mixture, but the sand will settle to the bottom. Homogeneous mixture, what? Mixture is uniform throughout, right? And what's a compound? Two or more elements that are chemically combined, right? It's not just a mixture of gases, of pure elements. Okay, so what is air? Some things in air are compounds, so like O2, this is an element, and it's really just an element, we'll leave it at that. So we have O2, what else do we have? We have helium, we have N2. So what kind of a substance is air? Air is all this. Can you see? You're looking at air. Can you see the difference? Absolutely not. But we know that there are differences there. So it is a homogeneous mixture. Yeah. Okay. Which of the following is a chemical change? Cutting a rope, chemical or physical? That's physical. It's still rope. Bending a steel rod. Still a steel rod. Making a snowman. Physical. Burning sugar. This is chemical. This is chemical. Melting gold. Physical. Anytime that you are just changing the state of matter, that is a physical change. Be careful with that. Changes of states of matter are just physical changes. Okay, which of the following is a physical change? Baking a cake? No, that's chemical. That's chemical. You put it in the oven, you add heat to it, that's chemical. You're going to change it into something different. Dry ice sublimating. This one's physical. Have you ever seen dry ice? Right? If you have a block of dry ice, and if you like leave your ice chest open or whatever, it just turns into vapor, right? So it's still the same substance. It just goes from solid to gas, right? Fermenting grapes to produce wine. Fermenting is chemical, right? Digesting a meal. Well, that's definitely chemical. And a tomato ripening. Chemical. Okay. How many calories are required to raise the temperature of a 150-gram sample of gold from 25 degrees to 175 degrees Celsius? The specific heat of gold. Did we do this one? As I say this, I don't think we did this in class. Did we do the formula with specific heat? I don't think we did. I don't think we did. Don't do that one. We didn't do that one. Right? I don't remember us doing this. Yeah, Q is equal to MC delta T. Did we do that? No, we didn't do that. That's what I thought. We didn't do that. Okay. I don't know. Y'all have taught so many different chemistries. When I put them on there, I'm like, okay, so don't do that one. All right, let's see, 30 to 38. Identify as physical or chemical change. Yes, I'm going to give you the exam resources for the final. The same ones you had for the last exam. Okay, water evaporating, physical or chemical? Physical, so I'll put an A. Silver tarnishing. That's chemical, it's reacting with the oxygen in the air. Cutting the grass. Physical. Oh, I'm supposed to do A and B. A nail rusting. Chemical. Baking a cake. Chemical. Placing photographs in a scrapbook. Physical. Formation of green leaves on a plant. Chemical. Burning leaves. Chemical. Ooh, it's supposed to be B. Melting ice. Physical. Okay. All right. Which of the following elements is a metal? What are you going to look at? Periodic table. D, strontium, I heard it, D, strontium. The rest of these are what? Non-metals, right? So the metals are on what side? On the left, and non-metals are on the right. Okay. Which of the following elements is a noble gas? What column are our noble gases? Argon, so it's column 8 or 8A or 18. Okay, so argon. Chlorine and bromine are in which one? Which category? 7, they're called halogens, right? Halogens. Okay. The element in this list with chemical properties similar to magnesium is, what determines chemical properties of any given element? Same group. Why? If they're in the same group, what's the same? They have the same, not outer shell, but they have the same number of when you're writing on your periodic table and you wrote, okay, this column's a +1, this column's a +2. So what determines that? Number of valence electrons, number of valence electrons. So as we go down the group, they're going to be in higher and higher principal energy levels. So they're going to be farther away from the nucleus. But if you're in group 1, everybody's got 1 valence electron, everybody. Okay, all right, so magnesium is in what group? So which other one is in group 2? Strontium. Okay. Which of the following descriptions of a subatomic particle is correct? And we're going to go through and fix the ones that are incorrect. Which one's right? Which one? Okay. A proton has a positive charge, that's true, and a mass of approximately 1 AMU, that's true. Let's fix the other ones. An electron has a negative charge, is that true? And has a mass of approximately 1 AMU. No, it's negligible, it's small. Negligible. A neutron has no charge, true or false? True. And its mass is negligible. That's false. It's approximately 1 AMU. So a proton and a neutron have about the same mass. A proton has a positive charge and a negligible mass. That one's false, right? 1 AMU. A neutron has a positive charge and a mass of approximately 1 AMU. No, it is neutral. Right? Okay, the mass number of an atom can be calculated from what things take up mass in an atom? Protons and neutrons. So you just told me which ones had mass. Now you have to tell me mass number. Well, it makes sense. All you have to do is count up the things in the atom that have mass. So we are protons plus neutrons, right? Okay. The correct symbol for the isotope of potassium with 22 neutrons. So go look on the periodic table and find potassium. What do we know about potassium? So here we have neutrons is equal to 22. What do we know about protons? We know that potassium has how many? 19, right? Our number of protons is the same thing as the what? Atomic number, or the number that's on the periodic table, that whole number in the cube. Okay, so when we write our symbol, we're going to have to include two things, a mass number and an atomic number. What goes at the top? The bigger one goes on the top. So what is the mass number? Our mass number is our neutrons plus our protons. So that's 22 plus 19. What do we get? $41, right? Okay, so mass number goes on the top. That's mass number. And then at the bottom goes atomic number. So what's our atomic number? 19. So always remember that when you subtract the two, you should get the number of neutrons, right? And if you subtracted the two, you would get 22. So that is correct. So we want 41 and 19. Yeah? Okay. Which of the following gives the correct number of protons, neutrons, and electrons in a neutral atom of SN 118? SN is 10. So this 50 is telling us our number of protons. This mass number here is telling us number of protons plus number of neutrons. So I know my protons is equal to 50. What are my neutrons? 68. What are my electrons? If it's neutral, it has to be the same. These two have to be the same if neutral. Right? So what do we got? Protons 50. So we got it here and here. Neutrons 68. Okay. Then that narrows it down to C. Is this helpful? Yes? Okay. 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 I didn't know what y'all normally, I don't know. Okay. Isotopes are atoms of the same element that have what? Let's look at the beginning. Are it the same or different atomic numbers? Must be the same because it's the same element, so it must have the same atomic number, which is what? Number of protons. That's what determines what element it is. So you have to have that. Okay, so we can eliminate A, but what's going to vary? Number of neutrons. If you vary number of electrons, what are you? You're an ion. If you vary the number of protons, you're a different element. Right? And then E have the same atomic mass. They can't have the same atomic mass because then they wouldn't be isotopes. Okay? All right, a sample of silicon has 3 naturally occurring isotopes. They were told what that isotope is and its mass, right? If the average atomic mass of silicon on the periodic table is 28.1, which isotope is the most abundant? So it's going to be whichever one is closest to the number that you see on the periodic table, right? So it's going to be A. How do I know that? This is something that you might have kind of forgotten. Do you remember that the average atomic mass is a weighted average? Remember that? So when you look at a regular average, like if you were calculating your exam average for our class, right? You would add up whatever you had and divide it by however many exams we had, right? So if you made an 80, a 90, an 80, and a 90, right? what would you have? An 85, right? But if it were a weighted average, what you would look at is its abundance. How often do we see one particular isotope over another? Well, we're told, right? We're only told the masses, but whichever one is closest to our mathematical weighted average, that is the one that is going to have the greatest percent abundance in nature, right? The more you have of it, the more it's factored into the calculation. So you don't have to be able to calculate the average atomic mass, but you have to know that it's weighted. And so the most populous isotope is going to be the one that is closest to the atomic mass on the periodic table. Yeah? Sort of? I'm not getting as much as a head nodding. All right, the number of electrons in the outer energy level of a neutral atom of boron, atomic number of 5, is what? It's 5, right? If it's neutral, our protons are equal to our electrons. Yeah? Oh, the outer, I'm not even reading it. Outer energy level. Oh, I didn't read it. Forgot about that. Okay, so what's the outer energy level? 3, right? Because it has 5 electrons. And then how many are in the lower energy level? You have 2. And then the next 3 are in the, so this is the first, this is the second energy level. Okay, good. Number of dots in the electron dot structure of carbon. We have 4. How did you know it was 4? It should look like this. How did you know it was 4? It has 4 valence electrons. That's what we draw an electron dot diagram, because these are the electrons that are going to participate in our chemical reactions. All right, this is just classifying things on the periodic table. So where are our noble gases? Y'all remind me of this? Group what? Group 8. Okay, alkali metals. Group 1. I'll give you a trick. Alkali metals are 1. Alkaline earth are 2. Alkali is shorter. Alkaline earth is longer, so it's the second one. Okay. Then what? If we're going along, we go alkali metal, alkaline earth. Then what? Then we have our transition metals, which are 3 through 12. Okay, then what? Non-metals, which are right of the staircase. Right? It's not really, it depends, because they kind of go diagonally, right? So right of the staircase. And then the halogens, group 7. Okay. So sodium, now that we know what these are to start with, what is sodium? Sodium's in group 1. So what is it? Alkali metal. Argon is a noble gas, right? So that's A. Bromine, halogen, F. Copper, transition, so that's E. Magnesium, alkaline earth, which is D, and phosphorus, non-metal. Which one of these could be categorized in another category? Bromine could also be what? A nonmetal. What else? What? If you could only use the answer choices once, that would be what you would say. Argon is also a nonmetal, right? Okay. What is the nuclear symbol for a radioactive isotope of copper with a mass number of 60? So y'all told me mass number is neutrons plus protons, right? So if I'm copper, how many protons do I have? 29. So what's my mass number? 60. Okay. In order to be copper, we have to have that number of, the same number of protons. Okay, the nuclear symbol of helium. We're doing pretty good, y'all. The nuclear symbol of helium is also the symbol for designating a what? A what? An alpha particle. An alpha particle. So do you have to know all the different particles? Yes. Yes. All right. So this symbol is 0, a -1, and an E. What are we? We're beta. Good. So could you make yourself a little table and draw out the different symbols? So know the nuclear symbols. Okay. Oh, we have a nuclear reaction. Y'all remember these? These aren't too bad, right? You just have to make sure that you balance what two things? The number of protons at the bottom and the mass number on the top, and then you just have to figure out which symbol matches those two things. Okay, so let's do our mass number first. 10 and 4 is 14, so we have to equal to 14. So 13 and what? 13 and 1. Okay, so this should equal 14. 5 and 2, 7. 7 and what are 7? 0. So what's a 1 and a 0? A what? Be careful, this has a mass number of 1, so it must contain what? Either a proton or a neutron. Those are the only two things that take up mass. So we are what? A neutron. A neutron. If you were a positron, you'd be carrying a positive charge. That's gamma radiation. Gamma radiation. Deeper little N. Okay. What is the radioactive particle released in the following nuclear equation? Well, look, we didn't have to add anything on this side. So what do I need in order to make 74? I need 72 and 2, so that makes 74. What do I need to make 159? 4. So what is this? That's an alpha particle, and you could write He, or you could do the alpha symbol, either way. So if you do the alpha symbol, it's the same thing. All right. A sample of cerium-141 for diagnostic test was dissolved in a saline solution to an activity of 4.5 millicuries per milliliter. If the patient undergoing the test needs a dose of 10 millicuries, how much of the solution should be injected into the patient? So what are we looking for? Now, this is the nice thing about multiple choice. If you look at all the answer choices, you are given a unit, right? And as long as they're all the same unit, you know that's the unit you're hunting for. So it says how much of the solution. You should know that's a volume, and in this case, we're trying to get to milliliters. So what do we want to start with? I know I have a sample that is 4.5 millicuries per milliliter, right? You want to start with something different? Doesn't matter to me. So 10 millicuries. I'll squeeze it in right there. Oh, we're going to start there though. I got to do this one. Okay, so if we have 10 millicuries, we want millicuries on the bottom, and we want milliliters on top. So what do we do? 4.5 and 1. So how much do we give our patient? 2.2. 2.2. Okay. All right, what is the half-life of a radioisotope? Put your answer choice in the chat once you figure out what you want. We'll do it that way. Somebody be brave and put the first one. Okay, so the half-life of our radioisotope is the time it takes for 1/2 of the sample to decay. So if you start with 100 grams after 1 half-life, how much are you going to have left? 50 grams. If you start out with 1 gram after 1 half-life, how much are you going to have left? 0.5, right? It doesn't matter how much you start with. A half-life is the time it takes half of it to decay, to become non-radioactive, right? You still have the other half of the sample that's radioactive, okay? All right, so now let's try to apply this. Krypton-79 has a half-life of 35 hours. How many half-lives have passed after 150 hours? You try it. I'm going to give you a minute. You try it. And then I'll work through it with y'all. You try it. We got 5 minutes. We end at 1:20, right? So sad, our last day. Y'all aren't so sad. Well, no, you are coming here on Thursday. It's our last class, though. You're coming here for the exam. You're coming in this building, in this room, but on Thursday at from 1 to 3, right? Yeah. Okay, we got it? We got an answer? All right, so what do y'all think? Put me an answer in the chat. All right, 3 half-lives. How did you figure that out? We see what happens, right? You have X amount, right? It has a half-life of 35 hours. So how many half-lives has passed after 105 hours? Well, we're going to have half of whatever we had, right? So then we have half again and half again. So 35, here's another half-life, that's 35 hours. How much time has passed? 35. How many have passed at this point? 70, right? So we go again for another half-life of 35 hours. What do we get? 105. So after 1, 2, 3 half-lives have passed in 105 hours. And you could do that really quickly by dividing 105 by 35, but it's important to kind of understand how that works. All right, last problem. The half-life of bromine 74 is 25 minutes. How much of a 4 milligram sample is still active after 75 minutes? So start with whatever your starting material is. We have 4 milligrams. Every 25 minutes, that number is going to get cut in half until we get to 75 minutes. So do your first half-life. This is 25 minutes. This is our first half-life. What's left? 4 divided by 2. 2 milligrams. Okay, so we have to add another 25 minutes. So how much time are we up to now? 50 minutes. And this is our second half-life. Right? Okay, now what? We're going to go to 1 milligram. All right. So we got to go again because we haven't gotten to a total of 75. So 50 plus 25 is 7. Oh, right. So this is our third half-life. And what do we have left? 0.5 milligrams. Okay. All right. I will let the tutoring center know where we stopped, and I'm sure they'll probably pick up where we left off. Do not forget to show up here for your exam. It is on paper, in person, study. Email me if you have any questions, and good luck. I know y'all are going to do great. Y'all have a good afternoon. Anybody on Zoom have any questions? Okay, I'm guessing no questions on Zoom, so I'm gonna go ahead and end the Zoom. Y'all have a great afternoon. If I can. Here we go.